Let's now talk about discrete random variables. Discrete random variables are random variables that can take only discrete values. We have discussed the case of the number of passengers in cars. Passengers can be counted 1, 2, 3, 4, and so on, and the number can take only positive values, and there is a finite number of outcomes. We stopped at 5, we could have stopped at 8, but I've never seen a car with an infinite number of passengers. Out of 1,000 cars, we have observed the following data, and we have rewritten the table in terms of probabilities. So we have divided each frequency by 1,000, the total number of cars. We define the probability of the outcome I as so the probability that the random variable takes the value Ri, and obviously we have that the sum of the probabilities must be equal to 1. If we wish to characterize the distribution by a single number, we can calculate the mean or expectation value. X bar equals mu, this is a Greek letter, equals E expectation value of x. It's just the sum of the value r times the probability that the random variable takes the value r. So in our case, x bar is equal 1 times 0.56, because there was a 56% probability that there was only one passenger in a car, plus 2 times 0.24, plus 3 times 0.15, plus 4 times 0.04, plus 5 times 0.01, and that gives 1.7. Notice, as we have already said during a lecture, that the expectation value can take non-integer values. Therefore, it's sometimes more practical to refer to the mode or to the median. The mode is the value which occurs most frequently. In our case, is 1. 560 cars have only one passenger. If two non-adjacent values occur a lot more frequently than the others, the distribution is said to be bimodal. The median is the value of the middle item when all data items are ranked in order. In our case, also the median is 1. The spread of the distribution can be measured by the variance. Variance of x is equal to sigma squared is equal to the expectation value of x minus mu, mu is the mean, to the squared. So you see all the required formula here. And the standard deviation is nothing but the square root of the variance. That's why the variance is sometimes written as sigma squared and the standard deviation as sigma. Obviously, sigma is the square root of sigma squared. Exercise. Birds of a given species lay either 0, 1, 2 or 3 eggs in their nests, with probabilities as shown in the table. Find, please, the value of k, the expected number of eggs laid in a nest, and the standard deviation of the number of eggs laid in a nest. Please do pause the video and try to solve the exercise by yourselves before going on. Pause the video. So that's the solution. The solution to the first question is obviously simple, because you know that the sum of all probabilities must equal to 1, and this must be equal to 1, must equal 1. So these are the numbers: 0.25 plus 0.35 plus 0.30 plus k equals 1. Hence k equals 0.10. The expected number of eggs is just the outcome times the probability. So 0 times 0.25, which is obviously 0, but I've written it for convenience sake, for simplicity's sake, plus 1 times 0.35, plus 2 times 0.30, plus 3 times 0.10, and this gives 1.25. The standard deviation is nothing but the sum, the square root of the sum of the difference between the outcome and the mean to the squared multiplied by the probability. So we have we haven't included we have 1.25 to the square, because 1.25 minus 0 is 1.25 times 0.25. That was the probability of finding 0 eggs, no eggs in the nest, plus 1 minus 1.25 to the square, which is the same as 0.25 to the square, times 0.35, plus 2 minus 1.25 to the square, times 0.30, plus 3 minus 1.25 to the square, times 0.10. And this is 0.94. So solve the same exercise, find the expectation value and the standard deviation of the outcome with the following probability distribution. Thanks.